Good morning, and thank you for joining us for a live talk with Sarah and Alex from Tokamak Energy, which is a rapidly growing commercial fusion energy company. It's great to see so many schools and individuals joining us today. And to celebrate National Careers Week, Sarah and Alex will explain about the career paths that they have taken, as well as what their day-to-day work is like within quality and project management. Please feel free to ask any questions by putting them into the chat, and Sarah and Alex will aim to answer as many as they can at the end of their talk. So that's enough from me. First of all, I will hand you over to Sarah. Good morning, Sarah.
Good morning. Well, firstly, thank you very much for having us this morning, and forgive me, I'm a little bit croaky, so we'll go straight in and do a few introductions. So my name's Sarah Terry. I'm a program manager. I've been in industry now for 11 years, but I've only been at Tokamak Energy for about a year now. And why am I here today? I want to tell you all about program management or project management. And now I'll pass over to Alex to introduce himself too.
Thank you, Sarah. So I'm Alex Slack. I'm currently the quality manager here at Tokamak Energy. I've been working in quality for over 20 years now, and yes, I do feel old. I say we both work at Tokamak Energy. Like Sarah, I've been here just less than 1 year, and the reason I'm here is to tell you how great a career in quality is. So I'll just tell you a little bit about Tokamak Energy first. So we're developing some clean, low-cost fusion energy. This is going to still be needed when the sun isn't shining and the wind isn't blowing. So as good as renewables are, we will still need a clean source of energy. But what is fusion? So fusion is the original source of all energy. Our sun and all of the stars are actually great fusion reactors. So fusion reaction is where two types of hydrogen, deuterium and tritium, which you can see at the top right there, they come together under very high temperatures and they fuse together to form helium and one spare neutron, which has got a lot of energy. And we can capture that energy in something called a tokamak to create electricity. And I'll hand you back to Sarah to explain what a tokamak is.
Thank you very much, Alex. Yes, perfect, that's right. So what is a tokamak? The tokamak is the machine that controls and confines that miniature sun. So the plasma, which is that sort of purpley pinky bit in the middle, that's where the fusion happens. Just to double check, I am, yeah, you can hear me, can't you? I was just double checking, had an odd message. So the tokamak is the machine that controls where the plasma is occurring. It's actually a Russian word that means a toroidal chamber with magnetic coils. That's where the word tokamak actually comes from. The tokamak controls our miniature sun because if you can imagine, it's very, very hot in there and that needs to be held. But we don't really have materials on Earth that can withstand such high temperatures. And therefore, we use these incredibly strong magnets that hold that plasma in place. And you can see those sort of sticking up. You have some that go around the edges and then some that go around in this sort of vertical point where you can see the cutaway there. What else needs to happen as well? Well, we need to remove all the particles away for that fusion reaction to happen. So it's just these hydrogen isotopes that are present that make up the plasma. And then we pull a vacuum. So a bit like in space, we take out all the air in the chamber before we start this reaction to happen. So it's quite impressive that we've got this really, really hot center in the center of the tokamak, but it's actually got to be really cold on the outside as well. So we really super cool the magnets down, and that means that they can work most efficiently. And then we pull a vacuum. So it's really, really impressive, impressive setup. And then how does this work? So the plasma and that reaction that Alex talked you through generates a lot this neutron with a lot of energy, and then that has generates the heat. And what we do, a little bit like a conventional power station, is that we will then harness that heat to convert it into electricity. And then this is the idea of how the tokamak will become. That's a really brief overview. We're still developing all of this, so it's a really exciting time to learn about fusion and see where it can get us to. But anyway, that's a really sort of brief skip through. And now I'm going to tell you a little bit more about project management. So starting with my journey into project management, I'll take you right back a few years to when I was at school. And I enjoyed maths and physics, and I also studied German and music when I was at school. I didn't really know what I wanted to do, which I can imagine a few people out there can share. So I thought I like applying problem solving. I like understanding how things work. So I decided to study engineering at university. I then went on my first job after university. I was very lucky. And I went into a job where I was looking after the part of the design of the, so this was an engineering job originally, of the Royal Navy's submarine reactors. So that's like the engine that powers the UK submarines. And over a period of about 10 years, I did a range of engineering roles. And then I went into some project management roles where I started delivering projects. And then that took me onto this role at Tokamak Energy, where I'm a program manager looking after high power, high performance magnets, and looking at this test facility that you can see up on the picture on the top right there. So if you can jump onto the next slide. So here's a silly slide of what is project management or program management. Well, my colleagues think I just look at spreadsheets all day and look at different plans and things. I'm pretty sure my family think I just drink tea and think up good ideas all day. But what do I actually do? Well, just before I jump on, that picture on the top right hand side is a full Tokamak's worth of super magnets. So there's 28 of those sort of circular oval shaped magnets, and then there's 16 in 2 stacks of 8 of the big round ones that you can just see a little bit yellowy in the middle. So if we jump to the next slide, let me tell you a little more about project management or program management. Well, projects come in all shapes and sizes. So some of these you might be more familiar with, whether it's a big stadium being built, the next Coca-Cola Christmas advert, or perhaps an app upgrade, or the next version of the GoPro. Or we go bigger and we think about, that's for anyone who's based around Wales, that's the old Severn Bridge that you can see there, or perhaps something like a house extension. These are all projects or programs of different shapes and sizes. But what does a project manager actually do? Well, we try and drive the success of the program or the project by looking at the overall plan. We might need lots of different teams, lots of different equipment, lots of different parts to all come together at once. We also need to manage the amount of money that it's all going to cost. And we need to make sure that we don't spend all of that money in the first sort of 5 minutes. We need to make sure that we plan that out and that we keep an eye on how much money we've got to spend in our budget. We look after the team and who needs to do what, and we look at the outputs. There's no point in having a loft extension if we don't have stairs that lead up to the loft. So thinking about those requirements and making sure that everything is captured. And then I think the only thing that I'd say there is a project is all around a sort of a defined set of time. So if you imagine an app like, let's say, Facebook or TikTok, that might be that wouldn't be described as a project in itself, because it's sort of an ongoing activity. Whereas the next upgrade of the app would maybe be the project. So that's a sort of a defined scope and a defined set of time. Hopefully that makes sense a little bit. But anyway, the project manager side is then how we're delivering all of them. So if you can jump onto the next slide, I want to tell you a little bit more about how it perhaps relates to what I do on a day-to-day basis. So here are all those ingredients that we talked about a moment ago. But what does that mean? So here in my Tokamak, I've got magnets. So I need my experts in magnets to be able to tell me what different tasks we need to develop and what we need to do and achieve. So I'll be having discussions with them. They'll tell me some technical work they need to do, or some further development and that sort of thing. We'll be looking at problem solving, because inevitably something doesn't go quite right. And they might need some more funding, and they might need some equipment and some tools, for example, to be able to build these things. I should start by I go back a little bit, and I should start by saying every day is different for me. So some days I might be, I'm constantly talking to people. I'm constantly in lots of meetings and chatting with different people and making sort of lots of different things come together. And I love that. It's a really interesting part because you meet some amazing people. And communication is really important to be able to do that because you're often knitting together lots of different things. But also I'll be looking at making sure that the briefing and the information that we need to underpin this, so like the funding, the plans, all the parts that are being delivered. So I'll be working with lots of different people to make this happen. So we need to make sure that the company, so we can't make it on site, it's too big, the big vacuum vessel, but we'll have another company somewhere else making these really big vessels that we've designed. And we need to make sure that they're ordered and that they arrive in time. So these are a few kinds of ideas of what we come to. And then to try and track all of that, because I can't keep it in my head, we have a really big plan that sort of models it all. So what do you, no, that's all right, we can go on to that slide, that's perfect, thank you very much. So what do you need for a career in project management? What's sort of maybe the takeaway for my messaging today? Well, we want you to be organised. If you're the one who organises all your sort of your friends' meetups or what your plans might be at the weekend, then that's a really good place to start. Leadership and enthusiasm, you need to often corral lots of people and get them to do whatever you want them to do. Or you need to get them to sort of deliver in a certain time frame and that sort of thing. So that leadership and enthusiasm. And alongside that, you need to be resilient because it's sometimes really difficult and people are often, we have really sort of conflicting views and sometimes you have to problem solve and sort of find that compromise of what approach we take. So that resilience is really important. And finally, I think the other really key skill here is communication. So a lot of my friends would probably describe me as quite chatty, which is probably why I've lost my voice a little bit. So it's really important that you have those skills. So those are some of the things. And if you can relate to that, then a career in project management might just be for you. But how do you get there? So you can go through university, you can go through an apprenticeship if university isn't for you. You can go into a job and you can take other qualifications in project management, which is pretty much what I did. So I started my career in engineering and then I transferred across. So it's one of these careers where it's really transferable skills. You don't need to know exactly what path you want to take to get there, but keep it in mind because it's a fantastic career to take. Anyway, so I'm going to hand you over to Alex now, who's going to tell you all about quality, but thank you very much for listening.
Okay, thank you, Sarah. So as I said earlier, my name is Alex. I'm the quality manager here at Tokamak Energy. But before I go too much further into my career path, just wanted to ask and try and get across what is quality. Is the phone on the left quality or the phone on the right? Well, actually, it depends on your needs and expectations. So a product can be said to be good quality if it meets the needs and expectations of the customer. So if you need a lower cost phone with a battery life that's very long and a phone that's almost indestructible, for you, a top quality phone might be the one on the left. If, however, you need to search the internet, look at videos, check your TikTok and social media accounts, you'll probably think the phone on the right is better quality. So, like many people, I didn't know what I wanted to do when I was at school, but I did study the STEM subjects, so the sciences, design and technology, mathematics. I went on to A-levels, but university wasn't for me, so I started working in hospitality. And strangely, working in the hospitality industry might have given me an insight into that key fundamental of quality, that it's meeting the customer needs and expectations. However, I soon got sick of working every weekend and thought that Monday to Friday was a better working life. So I got a job down in Swindon in Honda UK manufacturing. And that's where I got my first introduction to quality and working on development with our team in Japan on the lovely Civic Type R that you can see pictured in there. And like Sarah, quality is a wonderful career because it gives you lots of transferable skills. So I came out of automotive and making cars when the plant shut down, and I went into MSA safety systems, which made fall protection. So a completely separate industry in there. And you can see an example of their product, which is actually a vacuum anchor on the wing of an aircraft, which keeps that technician in the background safe while he's working on that and he doesn't fall off and hurt himself. And then from there, I've come over to Tokamak Energy, which again is a completely different sector and a completely new set of challenges. But again, what is quality? So there's two halves to quality. There's the quality control approach, which is I think what people tend to think of when they think of quality, which is about detecting and rejecting no good conform or no good product. That is quite reactive and can be quite expensive. Also, you've already made something. If you then test it at the end and find it's no good, it either needs to be reworked or put in the bin. Whereas the quality assurance approach is more proactive, so it focuses on making sure we've got good processes and procedures so that we meet those customer needs and expectations first time, and we're quicker, smarter, and all of that good activity that stops things going wrong in the first place. But I'll now take you through a day in the life of what it means to be a quality control person and quality assurance person. So quality control, as you say, it's about detecting and rejecting, which means measuring, understanding the outputs of the measurement, creating the reports. Again, like Sarah, there's the element of problem solving. We discuss with the design teams. We design new ways to measure items, which we've had to do on the lovely coils that Sarah has mentioned down there already, and you can see them down there with the team. And we also work with the supply base quite a lot. But they actually get to play with some of the more interesting toys we have on site for measurement, which is the 3D scanner, which has an accuracy of plus or minus 50 microns, and our coordinate measurement machine, which is a large fixed machine, that has an accuracy of plus minus 5 microns. But what on earth is a micron? Actually, a micron is 1,000th of a millimeter. So on the left there, you can see a cross section of a typical human hair, which is 50 to 100 microns. And 1 micron is that little dot in the bottom right of the cross section. So we can measure to very, very high accuracy in there. So I say the 3D scanner, which is portable, can get down to 50 microns, which is about the size of 1 grain of flour. They're very fine grain. And then the CMM machine, the coordinate measurement machine, can measure down to 5 microns, which is a little bit bigger than bacteria. And that's a lot smaller than you can see with the human eye, which tends to have a limit of about 40 microns. In our quality assurance side, actually, it's very different. We don't get as hands-on necessarily with the parts, but we do have a lot more team building, similar to Sarah's role. So we spend a lot of time working with the project team, which is why Sarah and myself have decided to come together into this. The roles are quite similar. We work with the design teams just to try and understand the design, confirm with them how we're going to measure it, what their needs and expectations are when it comes to measuring it. We do the problem solving. So again, when we do find something that hasn't gone so well, we do the problem solving and we try and strengthen our processes and procedures to make it better. So we have a better chance of getting it right first time the next time around. We do some auditing, which is confirming people are following the processes and procedures. We develop the process. We also do some quality training to the rest of the department. So getting that message across for what is quality and why we need it. We do our continuous improvement. So when you get into industry, those of you that go into industry, the plan, do, check, act continuous improvement cycle is very famous, and anyone that steps into quality will learn that one and will be able to recite it in their sleep. And we also manage the quality system for Tokamak Energy. But what do you need for a career in quality? Actually, the study that you can see on the right was carried out by the Chartered Quality Institute, and you don't necessarily need to be academic to have a career in quality. The more important skills are good communication skills. The personality traits that are being looked for is being high energy, being positive, being forward thinking, being a people person, and being a team player, because it, again, like the project side, it's about coordinating and managing and interfacing with lots of different areas to try and get everybody to get the good result. So actually, if you're a good communicator, if you are positive, good at interacting with people, if you're innovative and can solve problems and enjoy solving problems and are creative, again, that's an excellent trait for anyone that wants to work in quality. You do need to be organized and detailed. So you do need to make sure that what we've done is right and keep good records of it. But actually, you don't necessarily need to be academic, although a good grounding in the basics of the STEM subjects, your science, maths, physics, chemistry, design and technology will help you. And if it sounds like you, there are apprenticeships on metrology, which is the quality control side of things. And there are also training courses to become an auditor, to do the quality assurance side of things. So there are professional bodies for those. There's a Chartered Quality Institute and the International Register of Certified Auditors, if you are interested, and the website is available for those, and we'll send the links over as well after this for anybody that wants any follow-up. So thank you for listening. I think we have some time set aside now for any questions.
That's right. So thank you to you both. We've got lots of interesting questions coming into the chat. So I will hand you over to my colleague Sophie to put to you, either to any one of you. You can decide which is the best person to answer that question. So thank you. Over to you, Sophie.
Thank you, Lisa. Okay, so the first question I've got through is, actually, both of you can probably answer this one. What's the favourite part of your job?
So I can jump in first if you like. So my favourite part of my job is definitely working in a team. I love working with people, although they can be quite infuriating sometimes. And I think my favourite bit is then seeing what that whole team can achieve. When we sort of achieve a goal or something, that's such a great feeling.
Again, I'll maybe put my favourite part of the job in as well. I enjoy the problem solving side of things. That's really what got me interested in quality. So I love it when we've got something that doesn't work, or we can't do something and we're really struggling, and using that and sitting down with the team and working through something and then seeing it work at the end. That gives me a huge sense of satisfaction and puts a great smile on my face.
Fantastic. No, that sounds like you did both really enjoying your jobs there. That's really good. I've got a question. I think this one's for Sarah. What's the best engineering project you've worked on?
Yeah, okay. I'm going to cheat on this question. I'm going to give you two answers. So I'm going to give you one from my last job, and I'm going to give you one from my current job. So on my last job, I did a really interesting project that was really big, actually, and it was looking at how submarines go into dock. And so submarines have to come out of water and they have to go into dock. But in the UK, there is a small chance that we're going to have earthquakes. And so it's really important that that dock won't collapse. And so we did this really interesting project looking at, well, what does that mean? How do we design the dock to make sure it keeps everything really safe? But also, what can that submarine, we design a submarine so it's out on the oceans, and it's all doing all this sort of dynamic stuff moving around. I'm sure you've all seen some of the movies. So hitting that balance of how much protection it really needs. And that was really interesting because we did some really interesting analysis looking at it. In my current job, wow, so in Tokamak Energy, it's really fascinating because we're on the cutting edge of technology and we're learning new things. So our superconducting magnets, this is sort of a world first as we're applying these things. And it's fascinating hearing the team talking about these and the learning. So each day it's not sort of proven technology. We're learning how we do these things on a day-to-day basis. And that's really cool. That's really interesting.
Fantastic. Okay, so I've got a question. If you didn't do your current job, what would you do? Maybe we'd want to answer that, Sarah, and then we can ask Alex.
Yeah, of course. That's a really tricky question. I mean, I love the environment, and I also like sort of strategy and big thinking. So maybe I'd do something that was around sort of strategic kind of sustainability type stuff. I say that, but I also love the outdoors. So there's a good chance that I might just try and go and do something entirely different, like go and do some mountaineering or something entirely different.
Fantastic. And what about you, Alex?
That's a great question. If I did my current role, if I wasn't working in quality, what would I do? I could cheat and say I could go into project management because it's quite similar to it in a lot of respects. But if there was no constraints at all, I would love to, again, either be working in the space industries. It's something that always had my attention from a young person. But then so did fusion, and that's one of the draws for me that brought me into Tokamak Energy. So I don't want to be anywhere else. I want to be here. As Sarah says, it's so exciting to be doing things that nobody's done before, and to look at solving one of the big problems about being carbon neutral and producing energy without polluting the planet. It's brilliant. It's so exciting.
Well, could they use that for space rockets?
They
Fusion
could do,
energy.
and that is again something that is potentially being looked at, the alternative applications of these wonderful magnets that are very challenging but produce some absolutely amazing outputs when it comes to how much magnetic force they can actually apply.
Okay, right, I've got a question here. When do you think nuclear fusion will be ready to make electricity?
Now we have our small device at the moment, which has reached an outstanding internal temperature of 100 million degrees centigrade, which still to me sounds absolutely made up and mind-boggling. Our next device is being planned and being developed at the moment, and that should be ready 2026. And our experimental one to produce electricity for the first time, or produce more electricity than we put in, is planned for mid-2030s. So there are lots of challenges to still overcome to do that, but the roadmap is quite clear, and we understand what we need to do, and we have teams working on each of those different challenges for the mid-2030s.
Sure, no. So some of our students that might be watching now, so 2030s, yeah, they'll be well into their careers then, and kind of lots of opportunity. Lots of opportunity for them, really, shouldn't there?
Yes,
Fingers
definitely.
crossed.
Definitely.
Absolutely. Okay. Are there any apprenticeships at Tokamak?
Yeah, I can answer this one. We are aiming to start some apprenticeships from September. So we're still finalising the details, so there's nothing, no applications that you can do just yet. But if you keep an eye on our website for updates, then hopefully there'll be something on there quite soon.
Fantastic, that's really good to know.
We do currently have one apprenticeship as well, one apprentice on site in our environmental and radiation side. So it is something we are keen to be doing as a company as well.
Brilliant. No, that sounds really good. Can I get work experience at Tokamak?
The experience. Do you want to go first, Sarah?
I can. I've checked with our team while we've been chatting, because I saw this question come up. Unfortunately, it's not something that we formally offer at the moment, but it's something that's absolutely being considered for the future. So hopefully in not too long we will be able to offer some work experience, but it's not something that we've got in place just yet. There are other opportunities in other fusion companies so at the UK AEA, I know they do work experience programs that are pretty great. So if you want a taste of fusion, then do have a look. I probably shouldn't say that, but it's I've got a friend who's been on it, and it was pretty excellent.
Okay, fantastic. Do I need a degree to work in fusion energy?
No, is the simple answer. I don't have a degree, and I'm the quality manager here. So I say, depending on the role, obviously, if you need to be a plasma physicist, yes, probably a degree but level knowledge and possibly masters and beyond is what we need people working on that. But there are a variety of roles. As I say, Sarah does have a degree, but I have worked with project and program managers that don't. They've taken a working route into it. I've taken a working route into quality, and there's lots of other supporting functions around the business that may not need degrees as well. We need hands-on people. We need the technician style people who are actually building it. So it's all well and good having lots of big brains and scientists developing all these wonderful theories and designing the parts. We need people to make it and put it together and make sure it's built properly. So yeah, you don't necessarily need a degree.
Okay, I think we've got time for a couple more. What other types of jobs are there at Tokamak? So I guess apart from your own jobs, what are the other kind of job? I mean, you mentioned a couple before, yeah, which I can't remember already.
It's so varying. So we've got obviously our sort of jobs in quality and project management, we have, because it's fusion, we have physicists, so anyone who sort of specialises in physics. We have engineers, we have some chemists by background as well. But we also have other skills. So we have a finance team, so lots of sort of mathematical people there. We have a communications team, and so they're looking at how we reach out on our website and our social media and that kind of thing. So that's a really growing area as well, because it's really important that we sort of talk out to people. What else have I missed, Alex?
We have the standard sort of business functions, so human resources, so hiring and payroll and people's terms and conditions and bonus schemes. And the environment, health and safety is quite a big one for us here at Tokamak Energy. The health and safety executive and the environment agency are on site quite regularly, checking that we are being safe and following some good practices. So that's a relatively large team. I think it's more people in health and safety than there are in quality at the moment, which is quite right. We need to work in a very safe manner. So
Alex, I'd probably just mention one more in that we've got if you like doing things like working with your hands and in the labs, we have a whole range of what we call technician jobs, and so they're either helping us build things, or they're leading the research, the hands-on research as we're testing and trialing different things. So that's a sort of, it's more hands-on as a role, but you can then do like qualifications and sort of skill up as well as you're going through. So there's loads of opportunities there.
That sounds great. I think we've actually come to the end of our time with question and answers. So thanks so much. There's been loads of interest and you've done a great job of answering everybody's questions for them. I'm just going to hand back over to Lisa, who's going to just finish off now.
Thank you, Sophie. Yes, thank you very much to both of you. It really has been an informative and interesting talk this morning, and we hope our audience has been inspired to find out further about careers within the fusion energy industry. All sounds very, very exciting, and you clearly both have a passion for your jobs. So thank you very much for giving up your time. Just to let the audience know, we have been hosting live talks all this week, so you may want to have a look at our website and catch up what's been happening. It's been some really interesting talks from different industries such as automation, construction, conservation, and obviously today about fusion energy. So thank you very much to everyone, and enjoy the last couple of days of National Careers Week. Thank you very much. Bye.
Thank you very much for having us.
yes, thank you.